You might be wondering at this point why we bothered to come up with the concept of the mole. Well, right here, this paragraph right here. A mole represents the number of atoms it takes to convert from a single atomic mass in AMU, and remember, AMU is what we find on the periodic table, the atomic mass units, to the same mass in grams. And unlike in physics where it was all kilograms, we're allowed to use grams here in chemistry. The mass in grams of 1 mole of any substance is its molar mass, capital M. Each of the bars shown below equals 1 mole of a pure element. Here's 1 mole of copper, that weighs 63.546 grams. And here's 1 mole of aluminum, a lighter element, 26.982 grams. And right over here is a quarter, just to give you an idea of the size of these 2 mole elements here. Another comparison, if we take these little circles here and we fill them up, in this case 1 mole of carbon atoms, which is 12 grams, 1 mole of silver, 107.9 grams, you can see they're a bit bigger and there's not as many there, and this would be 1 mole of sulfur atoms, which is 32 grams of sulfur. And again, this is such an important point that we're finding different ways to show it to you. And the question here is, how's the atomic mass of an element, which remember is an AMU, related to the molar mass? Well, let's take krypton. The average atomic mass of 1 atom of krypton is 83.8 AMU. 1 mole of krypton, so that's 6.02 times 23rd atoms, that's Avogadro's number, is equal to 83.8 grams. Okay, so we've actually talked about this before this chapter, and now we're just giving more detail. So the atomic mass of an element, expressed in grams, is the mass of 1 mole, or just call it the molar mass, capital M, of the element. So 1 mole of krypton is 83.8 grams. The molar mass of krypton, 83.8 grams per 1 mole, and another way to write that, 83.8 grams per mole. Some more terminology. We can use the molar mass of an element or a compound to convert directly from masses in AMU, atomic mass units, to masses in grams. So we have 3 things here. We have elements, and we call that the gram atomic mass. And once again, should have said this first, everybody's in grams here. We use gram formula mass or formula weight for ionic compounds, and then gram molecular mass or molecular weight for molecular compounds. So you can see we're distinguishing between pure elements, ionic compounds, and molecular or covalent compounds. Here's a handy little conversion. Okay. N, little n, is the number of moles. That's a pure number. M, little m, is the mass of the substance, and that's in grams typically here. Capital M is the molar mass in grams. So you can see if you divide grams by grams, you get a unitless thing, and that of course is n. That's just a plain number.